Okay, guys, let's start then. Welcome to another monthly dev recap. The goal of this call is to present, to share with our community all the things that were built in the past month from our core developers. And then we are now dividing our call in two parts. The first part is the core developers update, where we share the evolution, the achievements of our core developers in the SDK part. And the second section, we share news and demo about applications that are being built on top of Cartesi. So please welcome. And on this edition, we will start with an introduction from Brandon from the Cartesi Foundation, talking about the technical evolution plan. So please, Brandon, come to stage. Welcome.
Hey,
Brandon.
everyone. Hey, Claudio.
Oh, it's very low. I don't know if it's only me. How is it for you guys? Can you hear Brandon well? Oh, it's okay? Okay, I will exit and back again. But Brandon, the stage is yours.
I think Claudio has an internal mechanism that turns down the volume in his own head when I'm speaking. It's good to be up here, everyone. I just wanted to give an exciting update. So the ecosystem's technical evolution plan has gone live on the Cartesi website this morning. I just dropped a link in the chat here, but you can find it on the Cartesi website under the About menu. So if everyone recalls, a few months back, the ecosystem kicked off on this decentralized process to create a first of its kind technical roadmap for the project. We had a technical vision council, which is a representative cross-section of both technical and non-technical Cartesi ecosystem contributors had been formed, and we had a lot of contributions from developers and community members proposing technical features in our governance forum. I think all in all, we had almost 40 technical features were proposed in the forum. The Technical Vision Council met and deliberated over the course of 9 meetings to come to an agreement on which features would be included in the first iteration of the ecosystem's technical evolution plan. And then we had a great effort from both the marketing department and our UX unit with UX Boost put together this really great visual for the ecosystem to visualize technical direction and progress for the project. So you can check it out on the website. Just a super brief overview. The first iteration is broken down into 5 categories. There's research and development, decentralization, and design space expansion is one category. Modularity and integrations, convenience and tooling, infrastructure and support for mainnet decentralized applications. And there's also a section on futuristic experiments. So encourage everyone to check it out. This is a really cool first of its kind technical roadmap for the project that was created in a decentralized manner with engagement and feedback from the community, core contributors, grantees. It's also meant to be a dynamic roadmap, so we're excited to see how this evolves. If anyone has any questions or comments or suggestions on how we can improve it, feel free to reach out. Feel free to comment in the governance forum as well. And I'll kick it back to you, Claudio.
Okay, thank you, Brandon. That's it, guys. Any question, please post on our chat, and then on the finish of our presentations, we can come back to this topic. Okay, so let's start the core development update. Who will be next? Marcel, Lineu, can you be?
Yeah.
Hello, Lineu. Welcome.
Hello.
Mike is yours.
How are you? Okay, thanks. 1 second. So I'm going to present about the Rollups Node 2.0. And so the first thing that I just want to recap really quickly is what is the node, right? So the node is I see the node as the central component for the Cartesi Rollups framework. So the node is getting input, rollup inputs from the rollups contracts. It's publishing the claims to the contract, so it has the paper of the validator. And it's also talking to the Cartesi machine, so it's performing low-level operations to handle the Cartesi machine. And it also provides the reading capabilities for the application front end. So it has the graphical API for reading the outputs and getting the proof so you can execute those outputs or validate them on chain. That's really important to manipulate the assets. And it also has the inspect capability, which allows the clients to run inputs in the Cartesi machine without sending them to the contracts. So I see the node as the central component. And so what are the main features for the 2.0? So I think the first feature that made this version be the 2.0 is the output unification. And this is a central refactoring in the rollups infrastructure. So as I was saying, the node is the central part, and this is the central change as well. So it really affects the node. And without getting into the details, the output unification is a refactoring really important for dApp, which is our fraud-proof system that's also being developed. So this is one of the main features and the drivers for this to be at 2.0 instead of another 1.x version. And in this version, we also going to support the quorums consensus. So instead of just supporting the authority consensus, which will still be supported, we also support the quorum, where multiple nodes will be required to validate an application. So this will be up to the application developer to decide how they set up the consensus. And another feature that's going to be on Node 2.0 is the concurrent inspect requests. We didn't talk much about it, but this will be there. We are currently rewriting the node. I will speak more about this later, but we are rewriting especially the parts that talk to the Cartesi machine. And then we will be able to, for instance, run an advanced request, and at the same time fork the machine and run an inspect concurrently. We will also be able to run multiple inspects at the same time. Just be aware that the Cartesi machine is required a lot of resources. So if you want to run thousands of inspect requests at the same time, you will need a big machine, a big computer. And we are also improving the node reliability and maintainability. So one big change that will impact the application developers is the change in the GraphQL. So initially we thought on doing just the low level, changing the GraphQL that the node provides into a low level one that will be simplified because of the output unification. But then after some feedback, and together with the help of the convenience and tooling units, we decided to provide a high-level GraphQL API on top of the low-level one. So the Cartesi CLI will provide these two tools together, and the node unit and the node itself will just have a low-level one that's simplified due to the output unification, and then the convenience tooling will provide another service that will run together, and it will have a high-level GraphQL interface that's similar to what we have today, and maybe it even has even more features. They will have the opportunity to work on that. So lastly, I want to talk about what we are doing. Now we are rewriting the node in Golang. So this is a big change for us. We were writing it up until now, we were writing it on Rust. We will still have a few Rust services, legacy services running, but most of the node will be rewritten in Go. And we are also changing the architecture a lot. So instead of doing multiple microservices, we're already changing this, but now it's the final step. We'll be providing the node as a modular monolith. So it will be much simpler. The code will be much simpler. It will be much easier to maintain. And this will facilitate the implementation of new features. So it will be better on the node unit side. So I believe we will be able to provide features much faster. And I also think that this will be good for prototyping, because now it will be much simpler for outsiders to take a look at the code and try to prototype it on it a little bit. And that's it. Thanks. I did a short version of this presentation now, but I will be doing a longer version of this presentation this Wednesday, May 8th, 2 o'clock Brazilian time. So 5 p.m. UTC. And the invite and more details are in the technical coordination channel. That's it. Thank you.
Thank you, Linneo. And thanks for this invitation. So everyone in the community is invited. Okay, let's move on. Danilo, can you come stage to bring Node, Rollups, Explorer updates?
Yes. Hello, everyone.
Okay. Well,
let me pull up some slides here. So the first section is Rollups contracts. Guilherme and Pedro are on stage.
Hello, everyone. So let's recap what happened on Rollups contract last month. Some interesting features. We've added delegate call vouchers, which allows many interesting use cases for application developers, such as having fully compliant ERC20 transfers and transferring assets to ENS identifying users. So delegate call is kind of complicated, so I tried to explain here a little bit how it works and what use cases it enables. Yeah. So this is a standard call you'd use to execute a voucher that transfers an NFT. So first you call the app contract, and the app contract calls the NFT contract. And if the recipient is a contract, the NFT contract calls the recipient contract. So all of these arrows are call. They are very simple. So the app contract currently can only do this type of call. So it can only do a single interaction with another contract and does nothing with the return value of it. So with delegate call, it allows interesting interactions with other contracts. For example, if you try to enhance the ERC20 withdrawal, it can process the return value that is returned by the ERC20 contract and check if the success flag is true, for example. So it makes the withdrawal ERC20 compliant. This isn't a problem in general because most contracts either return true or revert, but some implementations might opt to return false, for example. So an important difference here is that this dotted line is the delegate call interaction, and it preserves the message sender and the current executing application. So the safe ERC20 library is actually executing in the context of the application contract, and it can do operations on behalf of the application contract. And for example, do ERC20 transfers, etc. And so it can do also many calls in the context of the application contract. So you could have a library that does many operations atomically, and so if one of them fails, the whole voucher fails as well. So you could have like a voucher that calls approve, and then, for example, transfers assets to another application through the respective portal. So you can do a lot of interesting things and do interesting things with return values of these calls as well. For example, could you go to the next slide, please? Yeah, so one of the examples we made was to interact with users through their ENS names. So we've added a portal that tells the backend about ENS names and ENS nodes, so users can be identified by their ENS names, and they can make asset withdrawals to these users through their ENS names via this library, which is called through delegate call. So it first talks to the ENS registry, asks which resolver is responsible for ENS node, and it talks to the address resolver and asks for the address that this ENS resolve node resolves to. And finally, it talks to the ERC20 contract and transfers assets to this Ethereum address. So with this, you can have ENS identifiable users. Users can sell these identities and not have to expose their private keys. So it's a very interesting use case for game developers. And I'm sure the delegate call feature will enable many other use cases that application developers want to develop. They can just code their own libraries and interact with those easily. I think that's it.
Thank you, Guilherme. I'll move to some updates of the Explorer unit on behalf of Bruno. So the Cartesi scan had some updates the past month. We added a homepage for the application, which includes a summary of the inputs and outputs for that application. There is also a new section on settings. So the apps connection is now under the settings section, so it's more organized and more features will be added in the future for the settings. There is also a tab for in the applications page that shows apps that you own. And on the work in progress section, we are working on decoding vouchers for display and also decoding inputs by using some kind of specification language for those inputs. And soon the ERC 1155 deposits will also be live. I can show these features really quick in the presentation. Just a second. Right, so this is the homepage of the Cartesi scan. You can see a number of inputs in total, a number of applications, and my applications as I'm connected. These are the latest inputs, latest applications. So if you go to one of these applications, for example, this is the honeypot on mainnet. This is the new homepage that I'm talking about. This is the home of the application. It shows number of inputs, notices, vouchers, and reports. These are the latest inputs, and you can see each input here and information about the input. This is the new settings section, which is the connection to the honeypot node, right? This is the Sepolia one. We also have Cartesi scan for the Sepolia. So as you can see here, there is a My Apps section that filters the apps and shows those that I am the owner. Let me see. So these are the inputs. So the usual information, right? Going back to the presentation. So the only update for the Sonodo unit is that now the Sonodo CLI is a Cartesi CLI. We deprecated Sonodo, so users should uninstall Sonodo and install the Cartesi CLI instead. The documentation is up to date in the Cartesi docs website. There are instructions for installation and usage of the new CLI, so you can now run these commands instead: the Cartesi create, Cartesi build, Cartesi run, Cartesi deploy, and so on. Right, and Sonodo from now on will focus more on deployment and infrastructure for node execution, but the team will still be maintainers of the CLI, and the code has moved to a repository under the Cartesi organization. So that's it. Back to you, Claudio.
Thanks, Danilo. Nice to see the improvements on the Explorer, and also excited to see how our Cartesi CLI will progress. Pedro, you are on stage. Do you want to talk something? Complement anything?
I just forgot to leave the stage.
Okay, no problem. But the mic can be yours, no problem. Okay, just a comment. I like it a lot, the example that Guilherme presented about the atomic vouchers and its possibility. The mind is thinking a lot here. Okay, so I think our core developers presented their updates, and then we can enter in our second session about the applications. I would like to invite Carlo, Lino, and Rives team to talk about Rives. Hey, Carlo,
hey guys,
welcome.
Can you hear me?
Yes, very well.
Awesome. Can you guys see my screen as well? Is the screen visible?
Yes.
It is? Okay, great, thank you. Okay, so let's go for the monthly dev recap. So a lot of stuff happened in the past month. Just a tiny overview for the ones that don't know Rives. We're making this on-chain gaming fantasy console, which is similar to others that happened to exist like Pico 8 or TKD, which are virtual consoles. And this Rives is being powered by the Cartesi tech. Especially, we use a lot the Cartesi VM, which is RISC-V based. And with that, we were able to do some really cool stuff like running Doom in a verifiable fashion. A couple of stuff we're trying to achieve here. So one of the things we want to do is use the Web3 power so that people can submit and distribute their games in a few clicks, no bureaucracy, all the stuff. So popular, democratic marketplace in which you develop your game, and it's available in there with no big fees like you have on Steam or on Rio, Apple, Google Play, or any other stores. Another really interesting thing we have is that since all the gameplays are on-chain, we have this concept of tapes in which you can, after playing, submit it on-chain and verifying your gameplay. Anyone can just check what you did. So it's not just a claim of what you did, it's actually proof, and anyone can reproduce and replay it as they will. So this week we just made a really cool stuff. We had our first week of playtest on Doom. We had it started on map 2 and went up to the map 4. And today we're going to start a new playtest with a new version of Rives, a lot of improvements and feedback on it. And I invite you guys to join as well. You can do that by going to our Discord and joining the Vanguard initiative. We'll also have another week of playtest later. And on the 17th, we'll start our first game jam. So what does this first playtest look like? So we created this tournament, which is welcome to the Vanguard. You could play it. And once you do, you can just tweet or share your gameplay. And you have a URL that looks like this, vanguard.rives.io, tapes, and an ID. And if you click on it, you can just check what happened there. So for instance, this is a random gameplay that I just accessed. If you go for it, you can see all the things that the player did. You reproduce the entire match on your machine using the on-chain verified submitted data. This is actually a pretty good player. So, and just talking a bit about what made this possible. So these verifications, they are really tough. So there are multiple billion CPU cycles, and a lot of people playing in parallel would quickly pile up a single validator. So we have developed a pretty interesting architecture in which we have the Cartesi machine rollups node with a cache in front of it to serve all the read-only stuff that would just add overload to it, like what are the cartridges available, which are the games, how's the leaderboard, what are the rules available. So in this case, we have one rule for this Doom tournament. What are the tapes, which are all these replays from the players. And all this stuff is cached, so it doesn't hit the Cartesi Rollups node. And the verification of the games part, we did something pretty interesting. So once you submit the gameplay on chain, we have these validation workers that will, in parallel, process all the data, and will make a claim about that gameplay results. So we call this introspective rollups, because we have multiple rollups that do all the validations in parallel, and that post that result to the main Rives rollup. And besides that, we also have a traditional web server that just serves the base page that's made in React. This is a really cool architecture that can be reused by other applications that have the same problem of scaling the processing. Talking a bit about the Riv, which is the heart at Rives. So Riv has a couple of specifications, and that limits and makes the environment predictable. So it has a certain resolution, which is 256 square per default, but you can go up to 720p. The default and max frame rate is 60 Hertz. By default, we have a color palette with 32 colors, but you can change your own up to 256. Audio has 2 separate channels, so it's stereo. You can play 32 sounds in parallel if you want at a 48 kilohertz sampling rate. And as input, we have digital inputs for up to 4 players that can play a local co-op, for instance. We don't support mouse or analog at the moment, because that would be very tough on posting on-chain your moves. We're working on solutions how to make it lighter. But currently you can either play with a gamepad or a keyboard. And we have this guideline for you to use a clock of about 128 megahertz, so that anyone playing Rives will play it smoothly. But depending on your computer configuration, you can go like 4 times that. Currently, we have no accelerated graphics because that's really hard to emulate in a deterministic fashion. And the software rendering is done for the graphics. And we have this custom Alpine Linux, which is called RiveOS, which has a couple of facilities for it to develop your application, tools for debugging the code, and some nice amenities in there. We are also putting a limit on the processing of the matches, which is around 96 billion instructions. And that's a lot. So it's enough for you to play a 30-minute session of Doom, 2 hours of Endcopter, and depending on your game, it might be even more. And currently, we're limiting the RAM of these games on 96 megabytes of RAM. And though there's no limitation on the storage of the cartridge, we're currently limited to 0.5 megabyte, but that's quite a bit because cartridges are compressed, and we might increase it in the future if that's needed. So we also have a very extensive API on Riv, which you can use to play sounds like waveforms, like those old school Nintendo, Super Nintendo games. The graphics also support drawing fonts, changing color palettes, drawing text, sprites, shapes. We have also an API for getting the inputs, like the keys that the player pressed, up, down, for space, or gamepad A, all this kind of stuff. And we also have this universal input-output interface, which are used, for instance, to customize the games. So the tournaments for Doom, for instance, the rules that it's going to start on map 2, it's going to end on map 4, all this stuff goes through this interface. And the link here is broken, but we have all this documentation available, and it's published on docs.drives.io. So you can head there. There's a nice example of how to build a game, Snake game. And it stresses all the API, the graphic API, the sound API, all the parts that we have in there. Now, taking a look at this documentation, we are really excited to make our first game jam on the 17th. So it's going to be a week long, and it's going to have $1,000 in prizes. You can head on to each and subscribe in there and be a part of it. And yeah, we're really excited and looking forward to what the community will build with it. Now, for anyone wanting to know more about Rise, take a look at the games, play a bit on the Vanguard initiative on these playtests, or develop a game, or just talk about games in general, give feedback, please do join our Discord. We'll be happy to have you there. And yeah, that's it, Claudia. You're muted, by the way.
I was saying this was impressive. Really. Wow. Congrats for you and the team. Nice to see such a complex and interesting application on top of Cartesi. Wow. So that's it, guys. Let's start talking about some questions on our board. Let's start with Rev, just because Carlo is already on stage. I would like also to invite Milton, my colleague, to come to stage to comment things. He always brings nice thoughts, comments. There was one question from Crypto Gambler X. I think Lino already answered on the chat, but Carlo, if you want to comment something about where the gameplays are saved.
Yeah, so the gameplays, they're submitted on chain. Eduardo has made this really cool binary compression, which is super efficient. So they become really small. We don't know yet what's the mainnet base layer that we're deploying. But one of the things we're choosing is for it to be super cheap for you to just submit your gameplay and not break your account by trying to play, right? So, yeah, so just recapping, everything is stored on chain.
Yeah, this comment that you brought about you did compressing, you adopt a compressing algorithm to put the cartridge on chain in a cheaper way. It's one of the things that diagram that you presented with the validator nodes and. Wow, I think there is a lot of interesting stuff that you did on this solution. That's what made me impressive. How make it really cheaper and performant. You guys designed a lot of interesting solutions for the game.
Yeah, we needed both for the read state, right? Because inspect doesn't really scale fast, and we also needed a lot of solutions to make the validation fast enough in parallel.
Yeah.
So yeah,
nice.
Quite a challenge, but it's really nice seeing it all come together.
Great. And there is another one from Lincoln. Where do you sign up for the $1K Rives competition?
Yes, I just posted a link in there on the chat. So itch.io /jam/Rives1. Okay, great. So you can go there. You can join the game jam. And I also suggest that you join the Discord, because in there you can just talk to us, clear any doubts, give feedback, and important things for your journey.
Yeah, that's something interesting to say. There is a specific Discord server for Rives, right?
Yes.
Yeah, so
I'm going to post the link here. Yes.
Please do that. Thank you. Any comment about Rives, Milton? Are you also impressed like me?
Yeah, impressed, of course, but I know the guys, so yeah, they've been building this for a while. Really cool. At some point, maybe it would be nice to go a little bit deeper on the specific solutions and maybe things that we could work with the core units to sort out, right? Some things that may be more of a workaround solution for now, but could be done in a better way if we had X or Y feature. So yeah, some deeper technical discussion would be really cool about some of these some other time.
Yeah, we already had a session like 2 weeks ago, but we can definitely have another one.
And maybe if you have propositions that you would like to submit to the Vision Forum, that would be very welcome as well.
Sure.
Yeah, things that you had to implement, but if you had support already native in the SDK, it could make your life easier. So things like that could be good entries in the forum.
Yeah, just crossed my mind. One very interesting point of connection would be talking to the convenience and tooling guys who are working, as Linneo said, on a higher level GraphQL API, and what they are doing may be of a lot of interest to you. And actually, you could also give some feedback on the kind of features that they could add that would be especially helpful. But yeah.
Sure.
Thank you very much, Carlo. Do this again.
Yes. Thanks.
There is one of the first questions from Crypto Gambler. It was about the technical evolution plan and also about the DA integrations. Asking, assuming this is the lessons is coin, what's the latest progress update? When should DA integration expect? Milton, do you want to bring something about this work? Because we have been designing this for a while, and now we are excited to start really working on that. There is some prototypes. Do you want to bring something about the DA integrations? I think people are very interested about that.
So first of all, just remembering Cartesi is pretty much decentralized these days. So we have more than one initiative on this front, actually. So we have the the people from Lambada actually have been more advanced on this front. They've been experimenting already with Celestia and things like that, and also Espresso. And on the rollups front, we have been, for the last couple of months, discussing more deeply the architecture for DA and sequencer integration. As displayed on the TEP, it's something that has a core component, which is the generic machine I/O, which is reworking within the Cartesi machine for a more general way of transmitting and receiving data, which is what we usually do already whenever new inputs come to the machine. But this allows now to specify other sources of data besides the input box inputs. And actually, it wasn't mentioned here because it was already in the pipeline, but in the last week or so, this has been released as part of the emulator SDK version 0.18. So the generic machine I/O is already released. And now both Lambada and Rollups will start building on top of it. So this is expected to pick up steam in the next months. We have been having discussions on this channel that I just pasted, which is a machine I/O channel, which is named as such because all these integrations are based on this generic I/O capability that is now a reality. And specifically on the DA front for rollups, we are thinking about Celestia and Syscoin. I think Syscoin is actually okay. Yeah, Lambada is already on machine I/O. So we are doing like nice advancements on this front. You can follow up there, but we don't have specific timelines as of yet.
Nice. And Carlo is bringing here machine I/O is super important to enable a lot of interesting use case.
Yeah.
Carlo, do you want to comment something that you see that can also benefit Rives or anything that you...
Yeah, one of the things we want to use in Rives when machine I/O is enabled is dApp composability, right? So we can just pick up a gameplay of an old version and say, hey, old Cartesi machine, what happened here? And just fetch the result instead of having to retroactively support all the versions or stuff like this.
Nice.
Yeah,
so you
so-
see application for Rives also.
Yeah.
Yeah, and the kind of thing that Carlo mentioned, as Cynthia already posted there on the chat, and on the TEP that was published, actually displays nicely the relationship between this feature, which is the generic machine I/O, and these other possible features that we intend to implement on top of it. So the DA integration, sequence integration, this idea that Carlo mentioned of integrating Cartesi machines, which is more of a futuristic experiment. I believe that's in that section there. But it enables, when you open the door for requesting information in a more general way, there are many possibilities that arise. But of course, we always need to take care to preserve the verifiability and the robustness of the solution, right? So everything with careful steps.
All right. One thing that we trusted Milton during the call, I don't know if you also got interested like me about the atomic vouchers that Guilherme talked about as one of the applications of the new delegated call. I was thinking about the possibilities of it to account abstraction, implementation, support on Cartesi, and also about a node topic that I don't see people talking a lot currently, but also relates to account abstraction, that was intent. I don't know if it also got your attention about that example of atomic vouchers and the possibility of doing atomic executions.
Maybe somebody from the contracts team would like to come up and go further on this. Guilherme.
Hey, Gui.
Hello. So what was the question again? Sorry.
Yeah, when you presented the atomic voucher application of the new delegate call feature, I was thinking about the possibilities of it to implement and bring support of account abstraction to Cartesi. I don't know if I'm thinking too far or if it makes sense, but also relates to a topic that were around for a while about intent, the possibility of you bring a complex task that is decomposed internally and then executed atomically. Did you think about that, or I'm mad?
Yeah, for sure. No, atomic vouchers like that component that just makes a bunch of calls is totally in line with modularity. Like you could have like a first call, just check if the block timestamp is past a certain number. Another one could check that the text transaction or origin is some known address. They could compose these little libraries into one big thing. And atomic vouchers is very in line with this modular mentality. As for contract abstraction, maybe Pedro has some insights.
Yeah, I don't know if account abstraction has a lot of relation with atomic voucher execution, because I think it's as a voucher execution is already unpermissioned, so I think it matters very little what kind of account is executing vouchers. I think the impact that account abstraction can have for Cartesi is to allow dApp to subsidize inputs, add inputs. So maybe we'll be able to have applications like a game for rides that can pay on behalf of their users to add inputs to the machine.
Yeah, that could work. I mean, that could work now even without like those EIPs that would change the Ethereum protocol. You could have a portal that checks like a structured data signature, and then the user could sign with their wallet the input they want to add. And they would send it to another party, which would call this portal with the signature and have like the guarantee that this input was added by that user on behalf of that user. So it's totally possible.
Possible that I think account abstraction helps that a lot, especially on standardization, right? Because now we'll be able to have wallets that already support it and have standardized protocol interfaces to do that. And if you do that today, you have to make a lot of innovative choices that I don't know if we will hold.
Yeah, it's always good to comply to a standard, right? Yeah, I agree.
Yeah, excited to see next steps. Milton, do you want to bring anything else? Anyone in the community has other questions?
We're just going to comment a bit on Felipe just commented on the chat, a lot of use cases for these complex vouchers that Guilherme and Pedro were mentioning. One such is particularly easy to grasp. The use case is paid vouchers, which is vouchers that pay the user that executed them. So you could have people being not having to pay for the transaction of executing a voucher, being paid back by the application itself. Cool application for that. Yeah, I don't think there are any other questions, are there?
Okay.
So anybody else has
that's it.
Anything else to say?
Cynthia.
I could add, as I mentioned before, that the emulator SDK 018 is out, and that goes together with the generic machine I/O that we already mentioned, but also some features that were mentioned before here in the dev recaps. One of them is virtual I/O. So support for that is included in this release, which allows things like networking for prototyping. So you can have a Cartesi machine that talks to the internet while you are playing around with it. You could map host files, have better terminals, things like that. So this is included in this release that is out right now. Just to let people know. Last call for questions.
Yeah. Let's wait a little bit. As Felipe is saying, everyone here has the mission to spread the word, tell your friends about Cartesi, about the things that we are doing. I think that's it, Milton. It was a nice call. Any final words for me? Welcome, and thank you everybody to be with us this time. That's it?
That's it. See you around, guys.
Okay. Bye-bye, guys. Have a nice week.